Hello, and welcome to Foundations for Algebra, Unit 4A, Lesson 5. Today's objective is scholars will convert numbers between standard and scientific notation. Okay, so let's talk first about what scientific notation's format is. The first part of it is called the coefficient. This is a number. It must be at least 1, but less than 10. So it must have one digit left of the decimal. And then we multiply that times 10 raised to a power. We have the base. The base is always 10. And then our exponent. So, converting scientific notation standard. What happens when we multiply by 10? So what is 5 times 10? Well, that's simply 50. What about 5 times 10 twice? 10 twice is 100. So 5 times 100 is 500. 5 times 10 to the third is 5,000. Times 10 to the fourth is 50,000. Times 10 to the fifth is 500,000. So you can see when we multiply by 10, we keep adding zeros, or we move our decimal point. So we move our decimal point from where it starts at on the 5. Remember that decimal point's always there. We move it over 1. We multiply times 10 to the 1. And we add a 0. We move it over again. And we have 10 to the second power. Okay? So, scientific notation takes advantage of powers of 10. So what happens if we divide by 10? Well, 5 divided by 10 becomes 0.5. Remember that negative exponents be dividing. 5 divided by 10 twice is 0.05. 5 divided by 10 three times is 0.005. By 4 times, 0.0005. 5 times is 0.00005. Once again, I keep moving my decimal point. In this case, I move it to the left. I'm moving my decimal to the left. So now let's look at how we convert scientific notation to standard. 1.32 times 10 to the 7th is 132. And then my decimal point is starting off here. I'm going to move it right 7 times. So 1, 2, 3, 4, 5, 6, 7. And this is where my decimal point ends up. The issue is some of these don't have anything above them. So we are going to add zeros for each of those. So we end up with 132 followed by 5 zeros, which gives us 13,200,000. Well, what if I have the negative 10? Remember we talked about the fact that negatives are dividing and they are moving our decimal to the left. So again, let's look at what we start off. We have 3,8, and the decimal point's right here. And we are moving it to the left 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm adding 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros, then 3, 8. So you notice when we have these negatives, we have very small numbers. So let's look at this one. This time I have 5.973. That is less than 10 and more than 1, so that's fine. It is a positive 10 to the positive 8th power. So we're going to move our decimal point 8 points to the right. It started out right here. So when I move it 8 to the right, I move 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to add those zeros. So the number I end up with is 5, 9, 7, 7, 3, followed by 5 zeros, which gives me 597,300,000. As you can see, you just keep moving your decimal. When it's a negative, we are making a small number. We're moving our decimal to the left. When it is a positive, we're moving our decimal to the right. So pause the video right now and try and do these last 3 on your own. Okay, so hopefully you're able to get these. These numbers are not super easy to say. So this first one, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So 11 zeros, 298. The next one we have is, let's see, this is hundreds, thousands, millions, billions, trillions. So I guess it's quadrillion, 982 quadrillion. And then the last one, again, it's a small number, so you've got negative. Point, and then you have 5 zeros, followed by 7, 1. Okay? So let's look one more time at the next ones. So the last thing we need to talk about is how we convert into scientific notation. So going into scientific notation. First of all, if it is a big number, it's going to be a positive exponent. So I'm going to go through and do these big numbers first. Let me highlight the big numbers. This is a big number. This is a big number. And this is a big number. And then this number and this number are small numbers. So these are going to be negative exponents. Those are going to be positive exponents. So that's the very first thing you need to think about. Then we're thinking about how far do we need to move our decimal point? Well, let's remember, the decimal point starts out right here. If it's not there, it's always, if you don't see it, it's always to the far right. So I want to move the decimal point over until I have just one digit to the left of my decimal. So I need to move it over 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So this is going to be 4.32 times 10 to the 9th power. It's a big number, so it's definitely going to be a positive exponent. That's what we're looking at, is how far do we have to move our decimal. Here, the next one, my decimal starts out here, and I'm going to move it all the way over to the right-hand side of this 7. So how many places am I moving it? I'm going to move it 1, 2, 3, 4, 5, 6, 7. Sorry. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spaces. So this one's going to be 7 times 10 to the negative 11th power. Next one, again, here it's going to be positive. Oops, let's try changing colors. Let's go back to a different color. Do this one black. We want the decimal to move here between the 3 and the 2. So it's going to be 3.24, because the only numbers we can get rid of are zeros, and only if they don't have any other digits past the 0. We're going to move this one. We want to move this one from here to there. So 1, 2, 3, 4, 5, 6, 7. So this can be times 10 to the 7th power. Again, positive exponents, because that was big. Next one, let's look at. This is going to be a negative exponent, but I need to move my decimal point from right here where it is to after the 6. So this could be 6.94 times 10 to the, how many spaces I move my decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 to the negative 13th power. And the last one, my decimal starts out over here. I need it to move over to here, because remember I need one digit past the decimal. So this is 1.548 times 10 to the, and this will be a positive exponent. I need to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to the 12th power. Okay, so go ahead and try these on your own, and I will see you all in class.